Good morning and welcome to webinar 8 in the Building Smart program series. This series is brought to you by DTE Energy and Consumers Energy. My name is Sonia Ponce and I will be your instructor for today. I had a couple of weeks of a break here. For the last couple of weeks, your instructor's been Chris McTaggart, who I know did a wonderful job. I attended some of his seminars, and he's always just an excellent and very engaging speaker. But I'm happy to be back with you. I'll be with you for the next couple of weeks. And so let's just go ahead and dig in here. Today, we're going to be talking about duct systems, air distribution, and duct sealing. But before we do that, I'd like to know who we have with us in the audience today. So we're going to do a quick poll. John, can you help us out with that?
Yeah, it should be up there. People can vote.
Okay, so because I'm running the show this time, I don't see everything, so I don't see the poll. So you'll have to pull that up, and let me see if I can switch screens here. I've got a couple different screens going, so I'll just have to be reminded to do that. Okay, we'll give you guys another couple of minutes because I know it's early. We're just jumping in here. And actually, I am getting a note that my band with my connection is unstable. So I'm going to turn off my video. Give me just a second to do that. I'll turn it back on later on for the Q&A piece, but right now I'm getting a note that says it's unstable. Okay. Do we have our responses yet, John?
Yeah.
Okay, awesome.
Yeah.
So looks like everybody answered, and we're kind of split today evenly between engineers, contractors, and some code officials. So welcome to all of you. I hope that this presentation has, I think that it will have something for each of you, and we hope that everybody gets something good out of it, some good takeaways here. So we'll try to take that into consideration. Your roles in the construction project as we're going along. Okay, let me get rid of that and move on. All right. So, what we hope that you guys will take away from this session today is that you'll be better able to discuss the role that duct leakage plays in HVA system efficiency, the role that it plays in system performance. Be able to discuss that with the homeowners, and then that contractors specifically will be better able to construct the duct joints and to be able to check their work, be able to identify and repair leaks when they occur. For code officials, we're hoping that you get a better understanding of what to look for when you're looking for duct leakage test results in particular. And then for the engineering side of things, hopefully folks will be in a better position to better specify the requirements for leakage testing and for duct work in general. Very often, sometimes when you have an architect or an engineer involved in a residential project, a lot of times the certain aspects of the ductwork are left to the contractor, and But we want to make sure that if those two entities are not the same, if it's not the builder who's designing the house, that we do have some really good and clear specifications so that the builder knows what they're tasked with constructing. So hopefully those are some of the things that you get out of this session. What we're going to talk about today, we're going to go over the air system, the air distribution system. We'll talk a little bit about leakage testing. We'll talk about duct construction. And very specifically, we'll talk about fastening and sealing ductwork. Those are two really key things for high system performance. And key for energy efficiency. We'll talk a little bit about system maintenance, and then we'll just kind of wrap things up. All right. So the purpose of the air distribution system is to really kind of move air around the home, right? The purpose of moving that air around the home, that air is doing work for us, right? It exchanges thermal energy with the air that's already in the spaces, right? It picks up moisture, it dilutes contaminants by bringing in additional air and also by ushering existing contaminants back to the furnace or air handler, what have you, where it can be captured and contained by the filtration system. The primary components of the air distribution system are the ducts themselves that convey the air, the outlets and that supply air to the spaces, and the return grills that take the air from the spaces, take the used air from the spaces back to the air handler where it can be reconditioned to be reused or diluted and reused. So the overall design of the air distribution system, it's dependent on a number of things. Most importantly, the load, the HVAC load, which is dependent upon things like what the house is made of, right? What are the construction materials? What activities are going on in the house? Is there an exercise room, for example, in the basement where people are going to be gathering and expending a lot of energy? What kind of kitchen is there in the house where people are going to be cooking, and there's going to be a lot of moisture added to the air in that particular space, as well as in bathrooms. How many bathrooms are there? The showers are just tubs, those types of things. Laundry, all of these things are adding load, HVAC load, heating load that needs to be managed, right, and dealt with and or extracted from the home. So that's the HVAC load, and the air distribution system, which is tasked with managing that load or taking care of that load, has to be sized for that. It also depends on the size of the equipment, the equipment capacity, right? How quickly can the equipment take care of this load? And since air is one of the working fluids, how much air is this system moving around to take care of that load, right? And then, of course, obviously, the size and the type and the location of the air outlets and the air returns. So all of this impacts the air distribution system. Right. Designing the air distribution system is pretty much a straightforward process, but it is iterative, meaning that you might have to do steps, more than once. You may have to go back and redo something if you get to the end and you find, okay, I don't have enough air, or this isn't laid out right. I'm not getting air to this particular space. Then we need to go back and we need to look at things again, because we want to be sure that we have an adequate quantity of returns in particular, so that we get the right amount of air volume coming back to the air handler from the conditioned spaces, and that we're not drawing that air from unintended areas like attics or crawl spaces, things like that. And then the second step in that design process is we need to select and locate the type and size of air outlets, the supplies, right? And then we lay out the ductwork, right? Now, when we're laying out this ductwork, there are a number of things to take into consideration. The shape of the ductwork. Are we going to use round or rectangular duct? Round duct tends to have less friction, so it has less resistance to airflow, which makes it more efficient, right? So, which means it has less operating costs than rectangular duct, but round duct tends to take up more space. It can be more expensive to make and to install. And so we have to have that trade-off there. Whereas if we're looking at the rectangular duct, you're going to have, it may be easier to make, but you've got the higher friction. You may have more turbulence, so you may have more noise, which the homeowner may find objectionable. You also have to decide whether or not you're going to use all smooth duct work, or are you going to have any flex duct, which happens to be corrugated, right? The smooth duct work is obviously easier to keep clean, although cleaning duct work in the residential market has recently become something that more and more homeowners are aware of. Right. And so the smoother duct is easier to keep clean. Smoother duct also has less turbulence, so it's going to have less noise. And it tends to not hold condensation as much as flex duct as also. Right. The flex duct, however, is easier to install, particularly in tight spaces. Right. It can make turns and things like that. It's more flexible. Right. Hence the name flex duct. And it's less expensive, but because you get that corrugation with the flex duct, you tend to get higher friction and higher noise. Very often on the commercial side, there will be specified limitations for the length of a flex duct work, right? And flex duct work is used only for connections as opposed to full lengths of duct. And usually when that length is limited, it's usually limited to about 5 feet, is what we tend to do on the commercial side. I'm not saying that that's the same for the residential side. It's not. Typically, there are instances where you will see the entire ductwork is done in flex, except where flex is not allowable. For example, kitchen exhaust and things like that. But the other thing that you have to think about when you're looking at the duct design itself, how are you going to insulate the duct, right? Because wherever you have the potential for condensation, you want to make sure that you do insulate that duct. You can either insulate internally or externally, right? If it's internally insulated, that's typically called being lined, right? And this can give you better sound attenuation, right? Usually when we think about the insulation, we're really kind of thinking about moisture prevention, right? Condensation. But internally lined duct systems tend to be quieter, right? So some homeowners might like those. But they also have the potential for mold, right? Because mold likes dark spaces, and it's dark in the ductwork. And if there happens to be any moisture in there, that just makes it a prime space for growing mold. Internally lined duct can also be less durable because you've got air flowing across that lining all the time, and that lining tends to be just fiberglass. Now you can get that where the fiberglass is bound, so that it's less likely to erode over time. But being less likely to erode is not the same as not eroding, right? And so if you've got it externally insulated, this typically tends to be better for preventing condensation, particularly in areas where you have a lot of temperature swings. It's easier to maintain because it's easier you can actually clean the ductwork, right? And it's easier. It can, however, cost a little bit more, right? Because it takes more time. Now, because when you get the internally insulated ductwork, that usually comes with the insulation already there. If you had to install that insulation, that would be more expensive. So as you're considering all of these things, right, you want to look at, the location of the ductwork, and of course the homeowner's budget. And then the last thing that you do in that design process is, you want to make sure that it's properly sized. You want to make sure that the ductwork is the right. If it's if it's round duct, that you've got the proper diameter. If it's rectangular, that it's the right dimensions, right? And then you want to lay those out, right? Which rooms and which spaces are going to get supplies and returns? Are you going to have a central return, or are you going to have a return in each space? A lot of older homes, particularly here in the in Michigan, in Southeast Michigan, in particular, have central returns, right? Newer homes tend to have returns in each spaces, except for obviously the bathrooms and the kitchens. Um, you also, for example, don't want to put returns on outside walls, because you may draw, air from, potentially, right, if they're not sealed well, which we'll talk about a little bit later, but you may draw air from the outside. As you're considering the size of that ductwork, right, the diameter of the ductwork, or the dimensions for the rectangular duct, you want to make sure that you're taking into consideration the flow rate of the air through that ductwork. I don't know if that was my computer or not. I don't know if I can turn that volume off. Um, but you want to make sure that you're considering the duct velocity, right? So in your supply duct work, you want to make sure that your airflow velocity is somewhere between 5 and 900 feet per minute. In return, duct work, it's a little bit less than that. So between 4 and, say, for example, 7 feet per minute. Now, this is slower than what we see in commercial settings, and the reasons for this are, we want to make sure that we've minimized the noise, um, and we want to avoid issues like, high static pressure, um, but we also want to make sure that we get enough throw from those registers so that the air gets to where it's supposed to be, right? So um, we also want to make sure that we're managing or balancing, friction and resistance, right? So if their velocity is too high, this might cause drafts and things. And if it's not high enough, you don't get enough air flow out of the outlets, the registers, and then the home is not comfortable. So you're taking a balance of all of these things as you're designing this ductwork. And like I said, this is not just a once through thing; it is kind of iterative. Um, so you may have to go back and make some changes along the way as you're going through the process. Um, you may have gotten to the end and decided on a size for the ductwork and realized that you don't get enough throw out of that particular size. So then you've got to go back and reduce the ductwork. Well, if you reduce the ductwork, that's going to increase your velocity, and so then you need to look at, okay, well, what are you going to do with your registers and your returns for this increased velocity? Right? So taking all of those things into consideration. So the performance criteria for the ductwork, um, right? When you think about this, you've got three things that you're really trying to get here, that you're trying to obtain. So you want good temperature mixing, right? That air coming out of that air handler, out of that furnace, what have you, is going to be, if you're talking about furnaces in particular, that air is going to be, between 120 and 140 degrees. Right, so that hot air, it's going to be traveling through the ductwork. It's going to lose a little bit of its heat as it travels from the furnace to the point of use, to the room where it's going to be. But it's still going to be pretty high, when it gets there. And so you don't want to have, for example, stratification of air in the room, where you've got one temperature at the floor and you've got a different temperature at the ceiling. ASHRAE Standard 55 talks about limiting that vertical temperature differential, and the maximum that they recommend is 5.4 degrees Fahrenheit. And this makes sure that the occupants, that the breathing zone where the occupants are, which is between 3 inches and 72 inches above the finished floor, that there's comfort in that space, and that the occupants don't have, for example, cold feet in the wintertime, right? Since hot air is going to tend to, is more buoyant and going to tend to rise, right? So we want to make sure that we reduce that, that thermal stratification. This also helps to improve the energy efficiency, particularly in spaces where we might have high ceilings, and we do have a lot of homes like that here in Michigan, where people will have great rooms, which tend to have, you know, higher ceilings, and so you don't want that warm air to stratify up there. You also want to have a good air volume and pressure throughout the space. You don't want to create drafts. You don't want to have rooms be stuffy, right? So you want that temperature to be well mixed. You want it to be fairly uniform, and you want to have a good volume of air that you're sending to the spaces. So let's look at the components of the air distribution system. So when you've got a well-designed system, right, you're going to have an even distribution of air. You're going to reduce energy waste. You're going to have minimal noise. You're not going to have hot and cold spots around the space, right? And so this is what a good design system might look like. We'll just kind of look at, you know, what the components here are. So it kind of looks like a little octopus, right? You've got arms reaching out to all the spaces that are requiring the air. We're going to talk about the components one by one. I'm not going to talk that much about outdoor air, but that is a consideration here. Most older homes in Michigan here don't have a means to bring in outside air. Newer homes tend to some newer homes do tend to bring in outside air, and older homes, if they upgraded the insulation, for example, in the walls or the attic, they may bring in outside air. But most homes here in Michigan with forced air heating systems still aren't bringing in outside air. All right, so when we look at the distribution system, we start off with the furnace, right? This is the component that is providing the heat, right? And this could be a furnace, or it could simply just be an air handler. If, for example, a system had a boiler, this might have an air handler with a hot water coil in it. Right, but in most cases, people have furnaces that are using gas to heat heat the air that's transferred throughout the space. And so it could be a gas furnace, it could be an electric furnace, it could be a heat pump, right? There could be a heat pump here as well. It doesn't have to be a gas furnace, but you've got some component that's providing the heat, right? And then you've got two plenums. You've got a supply plenum and a return plenum. And that plenum is really just that central point connecting to the HVAC system. It's the connection between the HVAC system, the HVAC equipment, if you will, and the ductwork itself, right? So the supply plenum connects to the supply ducts. It blows the warm air out and then distributes that air through those supply ducts. The return plenum does the opposite, right? The return plenum connects to the return ducts. It takes all of that used stale air, if you will, and it receives that and through the vents, and then brings that back to the furnace or the air handler, where it is typically processed through a filter, cleaned, right, and then put into the air handler where it can be reheated, right? Because that air has, once it's come back, it's lost temperature, right? Because it's done its work, it's heated up the spaces, so it's lost temperature, and it may have contaminants to it. Now that supply plenum also will have typically a limit switch in it. That limit switch will monitor the air temperature, and then it sends feedback to the furnace. Right. So one thing it does is that it signals to the furnace that the plenum temperature has reached the appropriate level, so that it can then turn the fan on and start blowing air throughout the space. One of the things you don't want to have happen is the furnace comes on and immediately you start blowing cool air throughout the house. You don't want to do that. So you want to wait till the air gets warm, and then you want to blow that through blow that out to the house. It also checks to make sure that that air temperature doesn't get too high. And if it gets too high, then it will shut the furnace down. Now, again, as the air is coming back to the furnace, it's passing through this air filter, which plays a critical role. When filters were first introduced, they were really kind of introduced to protect the furnace. Today, we use them to improve our indoor air quality, to also protect the occupants. But that role of protecting the furnace is still a critical role. So we want to make sure that that air filter does not get clogged, right? Because that can impact the furnace performance, right? So we want to make sure that that does not happen. When we begin looking at the branch duct work, these are the branches that go off into the various rooms or zones within the house. They typically are smaller diameter, right? Because they have less airflow going through them than what you have at the main trunk, and they have less. They may have less airflow, and they also may have a higher velocity to make sure that the air gets to where it's supposed to be going. So we want to make sure that these branch ducts are just like the trunks, properly sized. We also want to make sure that they're not too long. We want to make sure that they don't have any sharp bends in them. And we want to make sure that they, just like the rest of the duct, are properly sealed. Two rules with the branch ducts is that, one, we want to typically have some space between branches. And that space typically is between 1 and 1.5 duct diameters. So you don't want to have two branches closer than that. This allows for better airflow. It reduces turbulence and things of that nature. And the second kind of rule that we have here is you want to have between 2 to 3 duct diameters of straight duct work before and after an elbow. So you don't want to have elbows too close to one another. You don't want to make a lot of turns in your duct work. Airflow is most efficient when it has a straight path and when you can kind of get a degree of laminar flow, right? That is most efficient for your fans and your electrical energy and things like that, right? And it also helps to reduce noise. So you want to make sure that you don't have elbows too close together. You don't want a bunch of turns in your ductwork. You want those runs to be as straight as possible, which is one of the reasons that metal duct tends to be preferred to flex duct. There are dampers also in the system. Dampers open and close to allow or control, regulate, or stop airflow. You want to have dampers installed in all of your branch ducts. These are for regulating and for balancing the temperature across different areas and the airflow across different areas of the home. Typically, when you get the system balanced, the balancer will kind of adjust those dampers to where they need to be to make sure that you're getting adequate airflow to all of the spaces. You may also have, in addition to balancing dampers, you may have some zoning dampers in the system as well. Boots. These are the metal fittings that connect the rectangular air registers and grills to the ductwork itself. So these help provide that smooth transition from the ductwork to the grill, right? And help reduce noise, help provide better airflow and make sure that the system is operating efficiently. All right, let's pause here and take a quick poll question. And John, can you help with that?
Yep, I got it
This
pulled
question,
up here. What should the length of duct be between takeoffs?
yes. Let me switch screens so I can see that. Okay, do we have responses?
They are still kind of trickling in, so maybe we'll give it another 30 seconds or so.
Okay, thank you. Okay, so we've got a couple different answers here. Um, but most people came up with the correct answer, which is 1 to 1.5 duct diameters. Absolutely, that's the length of space that you want to have between takeoffs. So some people might, I guess depending on if you're using a standard size ductwork and you're always using that size, and you'd say, oh, it's going to be 3 feet. But in general, it's 1 to 1.5 duct diameters, whatever that diameter happens to be. And if you used 1.5 to 1 duct diameter, that may be a little too close. And so you may end up with just some poor air distribution, some additional turbulence. You may not have air getting where it needs to be in the ductwork system, and so you may end up with some uncomfortable areas in the house. You may also have additional noise. So that 1 to 1.5 duct diameters, that's really kind of that sweet spot. That's where we want to find that's where we want that space between takeoffs to be. All right, moving on. Okay, so let's talk a little bit about duct leakage testing. So there are two types of duct leakage tests: total duct leakage and duct leakage to the outside. So when we're measuring the total duct leakage, this looks at the amount of air escaping from the entire duct system. It looks at the overall leakage from the system, whether it is leaking, whether the air is leaking inside the conditioned space or the building envelope, or outside the building envelope. And then duct leakage to the outside only looks at leakage to the outside, right, of the conditioned space, right? And both of these, leakage to inside or outside the building envelope impacts energy bills, right? The leakage to the outside impacts it a little bit more directly because you've conditioned air and then you've lost that air to the outside. But duct leakage inside can impact that as well because you aren't putting the conditioned air where it's supposed to be. So if you're taking air that you've heated or cooled and you're putting it into a space that doesn't need that heating or cooling, right, that doesn't have that load, then that air, that the energy that you use to condition that air is now wasted. And you've likely got to expend additional energy to combat the fact that you've now overheated a space or that you've overcooled a space, right? So those are the two types of leakage testing that we look at. Now, when we look at the total leakage testing, here, again, this is looking at inside or outside. So the building's ductwork is pressurized, and the total amount of air leakage is measured. If we use a blower door that's used to pressurize the building to a specific pressure, in this case, it's usually 25 pascals. This is relative to the outside. And then we the duct leakage tester measures the airflow through all the leaks in the duct system, right? Both inside and outside the envelope. Oops, meant to go the other direction. When we look at duct leakage to the outside, this one, we use a blower door, similar to what we're using when we do the thermal envelope air leakage test. So we use a blower door here to pressurize the building. We want the building to be at the same pressure as the ductwork, and that way there's no leakage between the ductwork and the building, right? And so this test is then looking at just the leakage to the outside. Now, the duct leakage testing can be done at a number of different, or at two different points within the building construction. It could either be done before construction is complete or after construction is complete. So when it's done after construction is complete, the requirements for the test are that we have no more than 4 CFM per 100 square feet of conditioned floor area at that 25 Pascal marker. And that is for either a total leakage test or a leakage test to the outside. When we do the test before construction is done, so when we do it at rough-in, we have the requirement is for total leakage, right? And the criteria change a little bit depending on whether or not the air handler is actually installed at the time of the test, because it doesn't have to be. So if the air handler is installed, the criteria is the same as it is post-construction, right? It's 4 CFM per 100 square foot of conditioned floor area. If the air handler is not installed, then we get a little bit of grace, and the leakage has to be or the leakage, I'm sorry, it's a little more stringent, and the leakage has to be less than 3 CFM per 100 square feet of conditioned area. Now, the leakage testing form would be, provided to the code official, and would indicate whether or not, what the leakage level was, whether or not the system passed. One of the things to note here in Michigan, our current residential code has I guess a loophole in it, if you will, that says that testing is not required for ducts and air handlers if they're located entirely within the building thermal envelope. In the past here in Michigan, we kind of felt like, okay, if the leakage is, if the duct is leaking a little bit, but it's still leaking inside the house, right? It's still leaking inside that thermal envelope. It's not that big of a deal because you still got that conditioned air in the home. But we now realize that, that just because that conditioned air is in the home doesn't mean that the system is operating as efficiently as it could. Again, if that air is not getting to the space that it needs to get to, if it's going someplace and it's overheating or overcooling someplace, that's not what we want. That impacts, homeowner satisfaction. It impacts comfort. So we want to make sure that we don't do things like that. And so forthcoming iterations of our energy code may do away with that. I don't know. I can't say if they will or they won't, but I will say that our code is based on the IECC, International Energy Conservation Code, and current versions of that code, or that standard, if you will, have removed this option, right? So that they recognize that leakage, whether it's to the inside or to the outside, impacts the efficiency of the system. And so, so they've removed that. The Michigan Department of the Environment, Great Lakes and Energy has a really nice write-up on duct leakage testing for residential applications, and this can be found on their website. It's a really nice document that goes over what the testing is, how to do the test, and then what needs to happen if the test fails. So now let's talk a little bit about the materials out of which duct is constructed. So you have for ductwork materials, you want to make sure that, first of all, you want to make sure that that the duct itself has a flame spread index of less than 200 for the For some of the materials that go into the duct, that are part of the ductwork, particularly the fastening materials, you want to make sure that they have flame spread indices of less than 25 and smoke developed indices of less than 50, right? But you have primarily, or for residential applications, typically three materials out of which duct is typically made. It's either sheet metal, fiberglass ductwork, or duct board, or flex duct, right? And so the sheet metal is typically a galvanized or an aluminum sheet metal. Air moves really easily through this, and they can be they need to be insulated whenever you have the ductwork running through unconditioned spaces. That insulation, we talked about that earlier, can be inside or outside the ductwork. Duct board tends to be easier to fabricate than sheet metal duct. It's less labor intensive. So you have special tools that kind of cut the duct board into the shapes that you need. It's a lighter material. It tends to be a little easier to seal, to air seal. The duct board is, but one of the drawbacks of duct board is that, if it gets wet, which we talked earlier about, moisture and insulation being on the inside of the ductwork and problems with moisture associated with that. Because duct board is essentially fiberglass that's kind of been rigidized, right? If it gets wet, you have that potential for mold growth, right? So you don't want to provide that. And then flex duct, again, it's primarily we'd like to see it for transitions between the branch duct, or between the trunk and the registers and outlets, right? Because flex duct, it's easy, it's simple, it's light, it's less expensive, but it is prone to sagging, it's prone to kinking, which can all interfere with airflow and make the system less effective. Sheet metal thickness, one of the things that we note is as we're moving through as we're installing the ductwork, that as we get larger ductwork, the material has to be thicker. Note that these values here are in thickness inches, not in gauge, right? Typically, the higher the gauge, the thinner the material, right? So now with duct sizing needs to be done in accordance with ACA Manual D. This is what this prescribes how we design, layout, and size the duct system. The goal here is to make sure that you've got, that you minimize the static pressure and that you maximize the airflow so that you end up with an efficient, quiet system, right? This is used for both single and multifamily housing systems. So you want to make sure that when you're sizing your system, that you've looked at, is this a single family? What is the application? Is the single family or multifamily? When we are installing branches and takeoffs, we want to make sure that those runs are as short as possible. We want to make sure that we mechanically fasten all those takeoffs. You want to make sure that those takeoffs are designed so that they don't create high turbulence. And also, just a thing to note, the takeoff is actually a specific fitting that connects the branch duct to the main trunk, right? So we kind of think of the takeoff as the arm and the branch, but it's not. The takeoff itself is a specific component. So you don't want to, for example, use an elbow as the takeoff, right? You can use an elbow after the takeoff, but you don't want to use an elbow as the takeoff, particularly because again, you're trying to make sure that you've got a smoother airflow, right? You want to maintain that good airflow, air distribution for efficiency. The volume and balancing dampers. So we want to make sure that our room pressure differential between rooms in the home is less than 3 pascals, right? With the air handler running. So you want to make sure that we've got those volume and balancing dampers there in those trunks to be able to provide that. I see we're running short on time here, and so I'm going to speed this up a little bit. I'm going to move past the duct construction piece, and I'm going to kind of move forward to the duct sealing, because that's really where we wanted to spend a lot of time. And unfortunately, some of the other stuff appears to have taken a little bit more time than I anticipated. Probably because I put those poll questions in there. But as we're talking about fastening the ductwork, we want to make sure that that we take into consideration what kind of ductwork we're connecting. Are we connecting round duct to rectangular duct? Are we connecting flex duct to duct trunks? All of that is very important when we're talking about fastening ductwork. Right. When we're looking at putting metal to metal ductwork, there are many ways to do this. The most common ductwork connection for low pressure residential ductwork is the slip and drive connection. You've got an S cleat, which is typically used on the tops and the bottoms on the longer sides of the ductwork. And it's designed to slip into the drive cleat on the matching piece of ductwork. And then you've got the drive cleat, which is typically on the sides, on the left and right side of the ductwork, and that's what receives the S cleat. Note that fastening is not the same as sealing. So this is just connecting the duct to each other, the duct pieces one to another. And this is typically done at the transverse connections, right? Where you're connecting one piece of ductwork to another piece of ductwork. When you're fastening duct board to itself, you want to make sure, for example, that you use outward clinching stitch staples, that these are spaced every 2 inches apart. And those outward clinching staples, they tend to be, they provide a more rigid, more stable connection. And those are staples where, if you look, know what a staple looks like, typically when you look at a staple that's on a piece of paper, it closes in on itself and it clinches inward. Here, you want the clinch to be outward. When you're fastening duct board to flex duct, you want to make sure that you have a metal collar there on the duct board, that it's specifically designed for the thickness of duct that you're using. And those duct collars they have fingers, and you want to make sure that all those tabs, if you will, are flattened against the board duct, so that you do have a flat surface, and that you can get a good seal when you get ready to seal it. When you're fastening flex to metal, you want to make sure that you've got, again, that you use that takeoff collar, and that you have a good, and that you use a tie to tie that down. When you're connecting board to metal, you want to make sure that you're using, so that your screws to secure the duct board to a sheet metal piece, to make sure that you've got a strong connection. You want to make sure that the seal is going to be, here, actually, we're talking about fastening, not talking about sealing. So you just want to make sure that you've got a good connection between the duct board and the metal flange on the air handler. And you want to make sure that your fasteners, that your mechanical fasteners, your screws are evenly spaced. Typically, we see those like 6 to 12 inches apart. And the same applies when you're connecting duct board to the plenum, when you're connecting any duct board to the plenum of the air handler as well. I'm going to skip over this because again, I want to really get to the ceiling where I wanted to spend a good portion of time, and I'm not going to be able to, but I want to do I want to spend some time here. So properly sealed ducts, they improve comfort, they improve indoor air quality, they enhance the safety of the occupants, and they reduce energy costs, right? So when we're selecting sealants, we want to make sure that we've selected a proper sealant for the materials that we're using. If if we've got sheet metal duct, if it's galvanized or if it's aluminum, we want to make sure that we're using a proper sealant that's been that is compatible with those materials, right? We want to make sure that it also is a low VOC so that it's low polluting. We want to make sure that it accurately accounts for the expansion and contraction that we'll have with different materials, right? When those two materials connect, because you're connecting two different materials together. All right. You want to make sure that you properly prepare a surface when you're going to when you're going to add a sealant to it. So you want to make sure that the surface is clean. You want to make sure that you've used an appropriate solvent that is compatible with the sealant and with the materials that the duct is made out of. So you're going to seal all the seams, all the connections, the joints, the cracks, the holes, any place where duct penetrate, anything where you've got anything penetrating the duct. If you've got some testing ports or anything like that, you want to make sure that all these things get sealed, as well as where duct goes through walls and partitions. So the sealing of the duct depends on a number of things. One is on the size of the gap or the hole that you're sealing. So, for example, if you've got a small hole less than 1/8 of an inch in diameter, you can just use appropriate mastic for doing that, right? If, however, you've got a slightly larger hole, you may want to use a fiberglass mesh along with the mastic to make that repair or to make that seal, to make sure that you've got a solid seal there. So, right, we don't want any air leakage. For even larger holes, you may have to do a two-step process where you put some temporary tape on the gap or the area that you're going to be sealing, and then you add the fiberglass mesh. And really, that temporary tape is just there so that the mesh, the mastic doesn't fall through. Right, so you've got that fiberglass mesh there, and then you put the mastic on that. Whenever you do that, you want to make sure that the mastic extends beyond the sides of the temporary tape. For still larger gaps or leaks, right? If you've got a 3/4 of an inch gap or a leak there you want to use a rigid duct patch, right? So you're going to use the same material that the duct is made out of. You're going to fasten that patch up before you apply the mastic, and again, you want to make sure that the mastic and the patch itself are going to extend beyond the sides of the opening, right? So you want them to extend at least 1 inch beyond the sides. Whenever you've got whenever you have some ductwork going through a chase, you want to make sure, again, because you want to seal around the ductwork as well. So you want to make sure that you seal that. So you're going to seal here. Where's get my mouse on the page? Okay, here we go. So you want to make sure that you're sealing around where you're going to place the enclosure, and then you've got some solid material, right? This could be a block of wood, perhaps, or this could be metal, depending on what the nature of this ductwork is, right? But you're going to make sure that you seal that, seal that to the ductwork itself, right? And then if you've got insulation, you're going to add your insulation. You're going to make sure that your insulation is not touching your ductwork right there, right? So you've got some braces to keep that there, to keep the ductwork, to keep the insulation away. When you're sealing duct boots, here you want to make sure that you're eliminating any leakage around the boot connections, but you want to maintain access to the boot. So we're going to seal, we're going to caulk here where the boot is going to connect to the flooring here. We want to make sure that that grill, whether it's a supply grill or a return grill, we want to make sure that that is still removable, right? So before we before we install that, we're going to make sure that this caulk is dry so that this can still be removed for cleaning or access for what have you. Sealing the air handler cabinet, oftentimes your furnace will come with openings that are optional openings for things. You could have the gas valve, you could have the gas train enter on this side of the air handler or furnace, or on this side, right? So you've got an opening here. You might have a drain enter on this side or the opposite side of the furnace. And so you've got these optional holes here that often come with plugs, but sometimes when we're installing things in the field, we don't replace these plugs. We don't put them back. We don't move them from one side to the other. We just take them out and they get thrown away. We want to make sure that those plugs get put back in and that they get sealed with gasketing or what have you, because that can impact, again, the performance of the system. Right, air handler filter slots or furnace filter slots. This is one area that we often don't think about because it's just a slot. You want to be able to take that filter in and out. But we do want to, where possible, include a filter slot cover so that we aren't getting air leakage there. We also want to make sure that we've got the right size filter installed, right? And of course, we want to make sure that the filter has the proper pressure drop. But definitely we want to make sure that the slot is sealed on all the sides except where it is, where you're going to be inserting the filter. And then on that side, you want to make sure that you've got a cover, right? That's replaceable, or that's closable. When you've got metal vents and flues, you want to make sure these are handled similarly to other ductwork. But here, you want to make sure that you've got a duct collar to help protect. And because these are going to be hot surfaces, right? So you want to make sure that you've got a collar here. And so you want to make sure that you're able to maintain the appropriate clearance, right? So you want to have 3 inches of clearance between the flue and any insulation. And so you're going to make sure that you've got that collar there. And then you want to make sure that the height of that shield is at least 4 inches higher than the expected height of the insulation. And you want to make sure that the caulk that you're using here is high temperature or fire rated caulk. Right? When you're insulating ductwork, you want to make sure that the insulation meets the code criteria. It's got that flame spread index of no more than 25, the smoke development index of less than 50, and that it has the right R value. So the R value depends on where the duct is located, right? So it's out if it's inside the building but outside the conditioned space, R6. If it's outside the envelope of the building, then it needs to be R8. It also needs to include either a vapor retarder or some foil or a 3-perm vapor retarder on it, right? We want to make sure that our ducts are supported, whether they're running horizontally or vertically. There are criteria for duct support, so we want to make sure that we meet those. There's some tabulated criteria for there, and we want to make sure that that we meet that. So, for example, ducts are never supposed to touch the ground. If you've got straps that are supporting your ductwork and those straps are narrow, so for example, if they're 1.5 inches less, then you may want to add a piece of sheet metal so that you don't just have the bare strap like you see here. You have a saddle here to kind of distribute some of that weight. You want to make sure, for example, if you've got a piece of equipment that's going to be, you've got a duct heater or something like that that's going to be in there, that you've got support, that you've got adequate support for that as well. This is an example of a piece of equipment that you may have in the ductwork, and you want to make sure that you've got support, adequate support on either side of that, right? At least 8 inches in front of and behind that piece of equipment to make sure that you've got no more than 8 inches, right? To make sure that you've got adequate support there. To verify the sealing, again, you might want to do that duct leakage testing. Again, in Michigan, it's not always required if it's if the ductwork and the air handler are all inside the building envelope, but it's still a good idea to do it. Maintenance, it's not necessarily required. It's not specified. It's not called out in code for residential systems. But it's a good idea every 3 to 5 years to, to go ahead and inspect and clean the ducts when needed, right? So you don't necessarily have to clean them, but certainly inspect them, take a look at them, and if they need it, then clean them. Some signs of poorly performing ductwork. So when homeowners are calling you in, calling a contractor in because they've got some problems, they're usually complaining about high utility bills. Some rooms are hot, some rooms are cold, some rooms are stuffy or dusty. And so these are some signs that you may have, a poorly performing air distribution system. Also, obviously, tangled or kinked flex ducts, right? Whenever we see those. So when a homeowner calls a contractor in, a service professional to come in, they're looking for somebody to help them improve the efficiency of their air distribution and the overall efficiency of their system. And so these are the services that they're looking for a good service professional to provide, right? They want somebody to look at the entire system. They want you to evaluate the air balance. How well is air getting from one space to another? Identify the leaks and seal them all, right? We want to look at, we want to make sure that the entire duct system is sealed. And then obviously, you want to install a new air filter and reevaluate the air balance after that new air filter is installed to make sure that you're still getting proper airflow. And then you want to, after you're sure that the air distribution system is performing like it's supposed to, then you want to look at things like look for backdrafting, make sure that there's enough airflow throughout the entire space. But then you also want to look at the rest of the house. Where might there be air leaks there as well? And then you want to educate the homeowner. All right. So the quick couple of steps here, and I've just got a few more slides here. If you can bear with me for 3 more minutes or so, I'll get through this. So we want to make sure that as you're finding leaks, one of the first things you do is talk to the homeowner, ask them questions. Do they have drafts in the house? Is their equipment cycling frequently? Are there ducts in the attic? Do they have a history of ice dams? All right, all of these things will give you more information and give you a better understanding of what the homeowner is dealing with and help you better identify what kinds of problems they might be having. And then, of course, you want to take a look at that duct work, right? Do you have places where, for example, you have flex duct that has gotten, through vibration, it's disconnected, right? Is there poor sealing? Right? Is there a leak, at the furnace, at the filter, right? Or are there any kinks in the flex ductwork? Right. So we want to look at those things, right? And then we want to make sure that we seal any problems that we find, any leaks that we find in the ductwork. We want to make sure that we seal them. We want to make sure that we do that properly. And then again, you want to look at the rest of the house. Where else might leaks be happening in this house that might make the house uncomfortable? What does the envelope look like? Looking at the soffits and ceilings. What are the utility penetrations? Is there an attached garage and how is that handled? Are there recessed lights? Are they sealed properly? All right. And with that, we're just going to go really quickly just through this recap and then I'll let you guys go. But just as a recap, so your duct system is designed in construction in accordance with Manual D, right? Your ducts are fastened according to a SMACNA criteria for HVAC duct construction methods, right? This applies to both residential and commercial applications. We want to make sure that we seal our ducts, longitudinally. They may be sealed with welds, the transverse connections, they're gaskets, mastics, and liquid sealants and UL listed tapes. You want to make sure that if you're using a tape, it's a UL listed tape, not duct tape, right? You want to make sure that you verify that sealing through either total leakage or leakage to the outside testing, even though it's not a code mandate. Or even though there's an exception in the code to that criteria, it's always a good idea to do it, particularly if you're trying to do a high performance home, right? If you're talking to if you're doing a smart home or a high performance home, right? You want to make sure that you do that. And then you want to make sure that you maintain that system with inspections and cleaning or repairs as needed, right? So And with that, there are a number of references that speak to construction standards and testing standards and sealing standards, as well as fastening standards for ductwork. So you might, if you're interested in looking at that a little closer, you can look there for those. And I just want to invite you out to our next session, which is next week. We'll be talking about hydronic and water distribution systems on July 15th. And there's the link. If you have not signed up for all of the sessions, you can sign up individually if you like to, or you can be signed up for all of them and you'll get an email reminder. And with that, if there are any questions, I will entertain them. If not, I know I went over 5 minutes, so I apologize for that. But I'll sit here for a minute just to see. And let me turn my camera back on. Okay, I don't see any questions coming through, so I will let you guys go. Thank you again so much, and I look forward to seeing you next week.